Hi, what's up people? Mr. Highway here. Today I'm going to share with you about chain rule. If you are learning about chain rule, then you must have already covered the basics of differentiation. If not, you can check out my video on basic differentiation in my series of differentiation videos as given in the link below. So to discuss about chain rule, let's start off with an example. Supposing we're going to differentiate y is equals to 2x minus 1 to the power of 5. Should we differentiate this, the power outside here, 5, power bring down power minus 1, or are we going to differentiate the 2x minus 1, which is inside the brackets? Or both? Well, the answer is both, okay? So first I'm going to teach you how the textbook teaches you. The way to do it is what we call chain rule, okay? Now before we decide that this is a chain rule case, we need to see that there's a bracket here that is inside, and then there's a power here that's outside, right? So we are going to do a power bring down power minus 1, but then there's other stuff inside this bracket. So we're going to let whatever is in the bracket to be called u. And u is equals to 2x minus 1. Okay? And if u is equals to 2x minus 1, then we can say that y is equals to u to the power of 5. So we have two equations now. We're going to differentiate each one. If you differentiate u, you get du by dx is equals to 2, because when you differentiate the x term, you get a constant term, which is the coefficient. Differentiate the constant term, you get 0. Now we differentiate the y. Y is on the left hand side, the u is on the right hand side. So when you differentiate, you get dy by du. And we have a power 5 here. 5 comes down. U to the power of 5 minus 1, or you can straight away write just power 4. Alright, so now the idea here is, if you want to find dy by dx, the differentiation of y, which is the original equation, then dy by dx is equals to dy by du times du by dx. Okay? So the idea here is this du here is going to cancel and you get dy by dx. Now, we already have what dy du is right here. Dy du is 5u4, but 5u4 is in fact equals to 5. U is 2x minus 1 to the power of 4, right? So we put it all in. 5 times 2x minus 1 to the power of 4 times du dx, which is 2. Well, so we put them together. We say that this is 5 times 2 is 10 times 2x minus 1 to the power of 4. Right, so that's the answer here. The textbook way is good to get students to start off. Okay, when you are learning this from scratch, you are new to this, you will need something to get you through step by step and to understand the process. Okay, however, when you are getting good, you are preparing for O-levels, you shouldn't be doing this anymore because it's too tedious, it's too long. You can't afford to do it with so much time. So what we do is we're going to use a shortcut method. And the catchphrase is like a phrase where you tell yourself how to do this thing. Okay, when I was a student, I always mumble it to myself, and I tell myself the step-by-step of doing this. Like I said just now, this 2x minus 1 is the inside. Okay, I call that inside, and this power here I call it the outside. So the chain rule applied here would be the differentiation of the outside. That means you power bring down power minus 1 times the differentiation of the inside. Okay, so now let's come back to this question again. Y is equals to 2x minus 1 bracket to the power of 5. So when we find dy by dx, we can straight away bring down the power, which is differentiating the outside. 5, 2x minus 1 to the power of 4. Okay, so you see that I'm differentiating the outside now. I'm focused on the power. I bring it down. We got to multiply by 5 in front. The power minus 1 is 4. Okay, then we times the differentiation of the inside, which is 2. Okay, then we multiply them together. 5 times 2 is 10. Bracket 2x minus 1 to the power of 4. Yep, so you can see that the working is much shorter. Okay. Eventually you have to come to this. Okay, when you start off, you do this, and you should be very familiar with it. Okay, and we are going to apply chain rule this equation here in other types of questions as well, so you might as well know it very well. So now let's look at some examples and see how this thing works. Part A, we're going to differentiate y is equals to bracket 3x squared plus 1 to the power of 10. This is pretty much like what we had just now. So when we differentiate, we go straight for the dy by dx. I'm going to do this by the shortcut way, okay? So we see this power here. There are two things to differentiate. First we have the power 10, and then we have this 3x squared plus 1 inside the brackets. So when we differentiate the 10 here, 10 bring down. Now when we differentiate the 10, right, you notice that what's in the bracket doesn't change, you see? There's no change to what's inside the bracket. We still have 3x squared plus 1. It's not differentiated, okay? We focus on only differentiating the power. Then we multiply by the differentiation of the inside. We differentiate 3x squared, we get 6x, 3 times 2 is 6. Okay, power 2 becomes power 1. Differentiate the 1 is gone, and so we have this. Multiply them together, you have 60x bracket 3x squared plus 1 to the power of 9. That's it. So let me label this. This is the differentiation of the outside. And this 6x here is the differentiation of the inside. Alright, part B. In part A, the question is given as y. In part B, we have fx instead of y, okay? So this means that we have to write the notation a little bit differently. We will have fx, okay? There's no y here. And we see the expression given here comes with sets, okay? That means like square root. We have to change them to index form, okay? In differentiation, you do not deal with sets. You always change it to index form. So we say that fx is equals to, now this means that I still haven't differentiated the equation, otherwise I'll get f prime x. 2 bracket, now this is bracket to the power of half, isn't it? Okay, because this is square root over the whole thing. But we have in the bracket a square root here and a cube. So this is x to the power of 3 over 2 plus 5 over x is actually 5x to the power of negative 1. Okay, so we change everything to index form, and now we can carry on with the differentiation. Now please do not multiply in the 2. You can't do that because this bracket here has got a power half, but the 2 doesn't have a power, so you can't multiply that in. And please don't bring this power half into each term as well. It doesn't work like that, okay? Remember your a plus b bracket square, you can't just square each term inside, right? Now we're going to differentiate, and we have f prime x, okay? So once I write f prime x, differentiation is being done in this line. You see the 2 here, just leave it. Power bring down, you have times half here. Whatever is inside the bracket, don't change it yet. Just leave it alone. Plus 5x to the power of negative 1, leave it. But this power here will minus 1, okay? So half minus 1 is negative half. Then we multiply separately by the differentiation of the inside. So we're going to differentiate this. 3 over 2 bring down, you have 3 over 2 x to the power of half, okay? 3 over 2 minus 1 is half. Bring down this negative 1, you have a minus 5 x to the power of negative 1 minus 1 is negative 2. Alright, so now 2 and half cancels, and we are pretty much done, but we need to always organize it, and so we will have this power here is a negative half. Negative half power means it's taking a square root in the denominator. So we put this square root in the denominator with x to the power of 3 over 2. This will be x cubed, same thing, square root of x to the power of 3 square root, and then plus 5 over x. Then we have a 3 over 2 square root x minus 5 over x squared. Okay, now this is kind of complicated, okay? Normally I wouldn't like to leave this denominator 2 here. I'll multiply throughout by 2, so you get times 2 over 2. You will have, this 2 will cancel with this 2, right? So you have 3 square root x minus 2 times 5 is 10 over x squared over 2 square root of x cubed plus 5 over x. Okay, and that's it. Part C. So first of all, C is given as an expression, so we have to deal with this properly, okay? Secondly, we have 3 over 2 here. If you notice this is in fact a multiple. So we are going to change this to the d dx of 3 over 2 bracket x4 plus 2x plus 1 to the power of negative 1. Okay, this is in the denominator power 1, so I'm going to bring it up to index form. And we have differentiate outside. You have negative 3 over 2 bracket. Whatever is inside the bracket, don't change first. And then the power negative 2. Okay, then we multiply this by the differentiation of the inside, which is 4x cubed. 4 bring down, 4 minus 1 is 3, plus 2x, x term you differentiate, you get a constant term. Then you differentiate constant term, you get 0. Okay, so now we're going to simplify this. You notice that this thing here has got a negative power, it goes to the denominator. Okay, this one has got no power, so it stays in the numerator. And as for the 3 over 2, this is numerator, this is denominator. So we have a negative term here. 3 is in the numerator, and 4x cubed plus 2 is in the numerator. This whole chunk takes a square in the denominator. So we have 2 bracket x4 plus 2x plus 1 squared. Okay, that's it. So just to recap about questions B and C again. This 2 here is the multiple, so I'm just going to leave it here alone. First, we will differentiate this power here, bring it down to the front, and you have this half here, then the power minus 1. Okay, so this whole thing is the result of differentiating the outside with the power. And this one here is the differentiation of the inside. In other words, this is the dy du, and this is the du by dx. Okay. Now, if you really want to try the textbook way, you can try, and then you see if you get the same results. Okay, noting that this is du dx and this is dy du. And as for this one, this chunk here is your dy du, and this one here is your du dx. Yeah, and your f prime x is du dx times dy du. Okay, likewise here, du dx times dy du. Alright, so now I'm going to give you a couple of questions. You give it a try and share your answers in the comment section below. What you learn here in chain rule is what I consider bread and butter in differentiation. So eventually, you're going to have to be able to do this very smoothly without letting u to be whatever is in the bracket, and then du dx, dy du, multiply together, and so on. Okay, you're going to have to do this just in one step, differentiate outside times differentiate inside. So if that's not easy for you, do practice a lot and get to a point where you're able to do this smoothly. Another thing to take note while doing chain rule is that when we differentiate the outside, we do not do anything towards the inside. Okay, so you see this, when we have power bring down power minus 1, this is not changed. This is where many students will make this mistake when they are new, where they will differentiate both this power bring down power minus 1, and then we differentiate whatever is in the bracket and we put them together with this 2, and there isn't this part here. Okay, and that's incorrect. Something you need to take note of, especially when you're new to this. Alright, that's it for this video. Share with me what other things you'd like to know about differentiation, and especially if you have any specific questions, please share in the comment section below. Like and subscribe. See you in the next video.